Start section 2.3. Function and function. Okay. So you already have these nodes, and there's graphs. That's why I say, okay, let me change the view. First thing, check here what it says. Define a relation. What's the meaning of relation? Let's show you an example here. The relation is a set of ordered pairs, x and y, is called a relation in x and y. It's a three definitions. We're going to focus on a set of ordered pairs. What's that mean? When you hear ordered pair, it means that's y. That's it. For each x, there is a y. Check the second definition. It says the set of x values in the ordered pairs is called domain of the relation. The set of y values in the ordered pair is called what? It's called the range. See, that's important. So now you know, like if we have a set, all x values is going to be the domain, and all y values is going to be. That's the first part. A relation is an ordered pair of x, y. For each x, it should be there's a y. And you're not gonna say just x by itself or y by itself. No, it should be x and y. So any point you can check. Like, for example, if you have 1, 2, this is ordered pair. 3, 4, this is ordered pair. -2, 5, this is ordered pair. So x, y, x, y, x, y, x, y. Okay? The domain, like for this example, the domain is going to be all the x values. So if I write down the domain, it's going to be what?
3, -2.
-2. If I want to write down the range, it's going to be what?
2, 4, 5.
2, 4, and 5. Write down this note. Do not repeat the number. They ask you to the domain, don't write down the domain twice. For example, if I have another order pair here, let's say 1 and 5, okay? And if I ask you to write down the domain 1, 3, and -2, that's it. Yes, there's a 1, but it's the same number here. Do not repeat the number again. There's a purpose for that. What about the range? Also, it's going to be 2, 4, and 5. I have 5 here and 5 here, but I'm not going to repeat the number when I write down the range. Is that okay? That's fine. I said of on any numbers is gonna, you're gonna say it's a relation. Now we're gonna add of the function. Now we're gonna check what's the meaning of the function. It's a relation, given a relation. That's in one of these. Okay, relation between x and y. But there's a condition. We say that y is a function of x if, put down line under this one, if each value of x in the domain, there is exactly one value of y in the range. So each x, there is only one y. Each x is a function. Okay? Check that with examples. A function, you have to satisfy two conditions. The first thing, it should be a relation. That's mean order pairs, okay? Should be order pairs. Like x and y. This is the first condition. The second condition, each x has only one y. Each X has only one Y. Is that okay so far? So, okay, how am I gonna figure it out? Each person goes to one place. Is that okay? Make it easier. Each person going to one place. You can go to Walmart, right? That's fine. Can you go to Walmart and HEB on the same time? That's not fine. This is the only condition make the function, make the relation not function. When, check here, when one person going to two places, that's not gonna happen. One person going to two places. So this condition make the relation not function. Now I'm gonna give you another. Is that okay? Two persons going to one place. That's fine. 100% going to Walmart. Thousands every day. It's fine. But can one person go into two places? No. So this condition is fine. This condition is what? The function, the relation, not a function. Is that okay so far? So now, I always prefer when they give me like example like 1 and 2. I always prefer to graph examples like this. If you can't do it from here, it's fine. If not, have two circles, two rectangles, it's fine. Let's see here. I'm gonna start from 3. I'm gonna go 2, 1. But that's important. If you look to the 3, person number -2 goes where? To -2. This is the place, this is the person. That's how we're gonna visualize. -2 goes where? -2. 6 goes where? Y goes where? Is that fine? For each X, there's a Y. This is the order pair, like -2, -2, 6, 6, pi, pi. So you can write down as a point, so everything is an order pairs. Each person going to one place, each X has only one Y, so it's fine. So this one I'm gonna say, because they're telling you if the relation is a function. So we're gonna type here, it's not a, sorry, it's a function. Number 3, it's a function. That's the result. She's gonna type function. That's it. Is that okay? Jump to number 2. Number 2, I always prefer to graph it like this. Let's see how it's gonna be. We can do it here. So number 2, 2. This is the X and this is the Y. Again, do not repeat the number. As we said here, do not repeat the number. Where is the domain here? This is the domain. This is the range, okay? Check, is the numbers repeated? The domain? No. Is the number repeated on the range? No. So do not repeat the numbers. Now tell me with number 2. Person number 1 goes to which place? 3. The second one, person number 2 goes where? Do I have to write down 3? Do I have to write down 3 here again? No, here's the 3. So person 2 goes where? Okay. Now the third one, 3 goes where? To 5. Is the relation as a function? You can tell. 2 persons going to the same place. This person going to HEB. You got the idea? So number 2 is going to be a function. You're just gonna type here, it's a function. But I'm telling you, you see, it's easier when you graph 2 rectangles and you put, do not repeat the numbers. That's the only mistakes you're going to do. If you repeat the numbers, it's going to be wrong. So the same number, when it's repeated with the range, keep just 1. And the same thing with the domain. Is that okay? Example 1. You solve it, but I don't know. Just gonna do this with x, y. Person number 2 goes where? 3, right? So I'm gonna put the line. And it says person number 2. Do I have to repeat it?
No.
The place is 4. Person number 2 going to the 4. And person 3 going where? 5. You can tell one person going to 2 places, gone. That's not a function. Now let's go back to number 4. The first thing I have to keep in my mind, the condition make the function is make the relation is not function is one person going to more than one place. Okay, I have to keep this one in my mind. Let's check this one. Y equal 2x plus 6. I'm not going to care about the 6. So every time when I plug in a number here, x, I'm going to get y. Plug in 0, you're going to get a new y. Plug in 5, you're going to get a new y. That's mean when I'm plugging in the x, I'm plugging the domain. The domain is the input. Right? I'm plugging the input here to get the output, right? You get the idea? So x is the input, y is the output. So when I'm plugging 0 in x, which is the input, I'm gonna get the y is 2 times 0, 0 plus 6. So person number 0 going to place 6. Is that okay?
Yeah.
Go ahead, plug in another number. Plug in -1. 2 times -1 is going to be -2 plus 6. So -2. Oh, sorry, I'm plugging -1. The result is going to be 4, right? That means -1 goes to the 4. Plug in another number. Plug in another number. Keep going. Keep going. Keep going. Each number you're gonna plug in is gonna be one place. You'll be fine. Like all the x value here, gonna go to only one y. Check here. The exponent. The exponent is not squared. The exponent is not squared. That's mean what are you gonna say? This one is going to be what? Is that okay?
Can you repeat that?
Okay. Every time, where is the problem? When I see one person going to 2 places, right? So if I plug in 0 here, do I get 2 places? No, it's only one place, right? If I'm plugging -1, do I get 2 numbers? No. If I'm plugging x, do I get 2 numbers? No. Is that okay? So this is a function. Let's jump. It's fine. Let's jump to this one. I'm gonna jump to this one, okay? To number 7. The same thing. So this number 4 is going to be what? Function. Number 7. X equal 7 minus y squared. First of all, I'm gonna solve it for y. Okay? So how am I gonna solve it for y? Move the x. And how?
Subtract 7.
Okay, so I'm gonna say -7 on both sides. Cancel here, so it's gonna be x minus 7 equal negative y squared, right? Then I need to keep the y. I'm gonna divide both sides by -1. That means from here, I'm gonna get y squared equal negative x plus 7. Is that okay? Let's do exactly the same thing. Gonna do two columns here. And by picking only one number, you're gonna figure out. By the way, you can do it from here. You can do it like this. That's fine. Both is going to be right. Now, pick any value of x. Pick any value of person. Pick a person. One. Okay, you choose one. You need to find the place, right? I'm gonna plug in one here. I square equal -1 plus 7. Yes or no? Now, -1 plus 7, y square equal 6. I need to find the person, not person square. I need to find the person. What I'm gonna do? Square root both sides. Square y square, square the 6. Y squared is going to be y equal the square root of 6. 2 point what? 2 point what?
2.449.
That's it. 2.45.
Plus or negative?
Don't forget the plus or minus. So when I put the plus or minus, y refer to what? The person, the place, right? So how many places?
Two destinations.
That's mean two destinations. So that's mean person 1 going to 2.45 and going to -2.45. One person going to two places. Is that okay? No. So this is not a function. Do we have to pick another number? That's it. One is going to be enough. So 1, 2 places gone. So this one is going to be number 7. Is not a function. Is that okay? So when you see an even exponent on the y, it's going to be a problem. You have to check it. It's going to be like this example, number 7. Okay. So now if you go here, you're going to tell me, by just visualizing, this is a function? This is a function?
Yes.
What about this one? We're going to check that. It's a function, but we're going to check that. Okay. What about this one?
Wait, it's not even.
Just one line. No, this line. I don't know why they put it here. But this is y cubed. I told you if it's even exponent. Is that even exponent? So this is what? Say it again.
Function.
It's a function. Okay. This one is not. This is a function. This is a function. Now let's check this one. It's a function or no? Because the exponents on the x or the y? On the x. That's mean. Let's check it. Let's see number 5. So now this is yes a function. This is not a function. This is a function. A function. Number 5. Y equal x squared plus 6. 2x squared 6. How are you gonna figure it out?
Put a 1 on the x, and then you work your way
Okay.
numbers until you get like an idea.
Yeah, but plug in 1. Let's plug in 1 for the x. Perfect. And if you have the idea,
It's easier, smaller numbers. That way you don't do too much work, right?
oh yeah. So now pick a number. Just pick a number
2.
and then create a table. So here's the x and here's the y. Is it a 3 or 2? 3. 3. Now the person is a 3. 3 squared 9 times 2 plus 6 24. I'm gonna put 24 here. Is that okay? Pick another number. Let's pick the 0. Okay, 1. Pick the 1. Plug in the 1 here. We get 24 here. Pick 1 here. 1 squared 1 times 2 plus 6. Here is 8. Now pick the 0. 0, everything is gone, so it's gonna be what? 6. Now let's pick negative numbers, right? Take negative 1. Negative 1 squared, 1 times 2 plus 6, 3, negative 3. Negative 3 squared times 2 plus 6, 4. Let's put everything on the graph. Okay? 3 goes where? 24, right? 1 goes where? 8. 0 goes where? To the 6. Now let's keep going. Negative 1 goes where? Do I have to write down 8 again? Here's 8. Negative 3 goes where? 24. Is that okay? Is that a fraction? 2 persons, 2, negative 3 and 3. 2 persons going to the same place. That's fine. 1 and negative 1. 2 persons going where? To 8. That's fine. 0 goes where? 6. So this one is what? Okay. So if you keep picking the numbers from both sides, 100%, negative 4 and negative 4 going to go to the same person. 5 and negative 5 going to the same place. 6 and negative 6 going where? To the same place. So it's going to be a function. The only problem where when you have even exponents on the y, like this one. Even exponents. If it's odd, it's going to be fine. It's going to be a function. Okay? Okay, so far? Saying vertical line test. So always when you have graph, by the way, on the previous examples, you can graph it. If you have a graphing calculator, you can graph it and you can use the same vertical line test to test if it's a function or not. Okay? So the previous examples, you can do the same thing here, but you have to graph the function first. Okay? Using vertical line test, a graph defines y as a function of x if no vertical line intersect the graph in more than one point. What's that mean?
Circles out.
The circles is out, you're right. But we need to understand what that means. When you graph the vertical line test, you have to make sure each person going to where? One place. That means you have to make sure the vertical line test, x going only to 1y. If x going to 2y, this is going to be a problem, right? So let's check with the first graph with the circle. We need to check by graphing a vertical line test. Choose randomly. Choose 2 lines. I'm going to choose one line here, right? Another line here. Okay? Now let's check. X on this point intersect on the vertical line test, you graph it. On the vertical line test, you graph it. X at this point intersect with the graph at how many points? 2 points, right? This one, this one. Is that okay? What's that mean? That means x at this point, where's the x? How many y? You can write it is the same thing. Now we have a graph. So that means x at this point has one y and another y. Just make everything is what? Add a function. That's it, done. You have to test the other one? No, I don't care about the other line. The test is going to be the same thing. 1x going to how many y? 1, 2. One person going to 2 y's, it's going to be a problem. The same thing with the other graph. Now tell me with the other graph. Graph 4, 5 vertical line test, doesn't matter. You have to make sure, again, 2 vertical line tests. Let's do one here. Other one where 2 vertical line tests. Now let's check. X at this point goes to how many y? Goes to only one y on the graph. Same thing here. X at this point going where? To only one y. At this point also x going to one y. So what do you think? Is that a function? It's a function. You got it? It's not that much hard. It's the same thing what we're doing here. You have to make sure, keep in your mind how it looks like the circle. What about the other one? What do you think? What do you think? Another graph. Be careful. Look to the graph. Let's check here. The graph started from this point and end here, right? And then start again from this point and goes up.
Not a function.
There is something wrong here. One of these points should be open circle. But you can't have open and a closed circle on the same time. Closed circle on the same time. So maybe it should be this one. Let me check the other paper. Should be something wrong with the graph.
That's not a function, right?
It should be function. But if you grab a vertical line test, yeah. On the graph you have, because this is not going to happen. Should one of these points, it should be open. When one open, the other one is going to be closed. Okay, the opposite. So if this point is open, that's mean the graph start after the point. Okay, so when you graph a vertical line test like this, it's going to define here, it's going to be undefined here. Okay, so this graph should be a function. Okay, they did mistakes when they put it. They put 2 dots. But if you look into this one without the open circle, yes, you're going to say it's what? It's non-function. Okay, so we're going to stick with this one. So if I graph a vertical line test here, this point, this x going to how many y? 2y. I'm going to say 1x going to 2y, so it's not a function. But I'm telling you, the original graph should be one closed circle, one open circle. That means when you graph a vertical line test, it's going to be x going to only 1y. Is that okay? So don't, with the graph with Alex, it's going to be fine. But they did mistakes here with this one. Is that fine?
As a closed circle and an open circle, that it's okay.
It's okay, because when you graph it, this is a piecewise function. This is a graph, it's called piecewise function. One open circle should be, the other one is going to be closed, or the opposite. It depends on how it looks like the function. So this one, we can study that in section 2.6, piecewise function, okay? Let's give you another example. It's not on the, we have here, it's also a graph. What about if you have, it's a graph. What do you think? This is a function? Well, by just graphing one vertical line test, this x going to how many y? 1x going to 2y. Ah, this is not a function. You got it? This is the same graph we have it. The y squared. The y squared equals something. It look like the same, like this. Okay? We're gonna study that again on section, I think 2.6 also. Next part, they ask you to evaluate. Evaluate the function. Apply function notation. What do you think? What's the meaning of evaluate? It means we need to find the value of y. What's the meaning of f of an x? Y. F of an x is y. So I have f of an x equal what? 2x squared minus or plus minus 3x plus 1. Keep in your mind, remember, what's the meaning of x? X is the input, the domain. Okay? X is the input, y is the output. So this is the input, and the result is going to be the output, which is the value of y. So when they ask you evaluate f to the negative 3, how much the value of x? F to the negative 3, how much the value of x? This is the x. I'm going to plug in instead of each x, negative 3. So it's going to be 2 negative 3 squared minus 3 negative 3 plus 1. Is that okay? Check. When I'm unplugging the number, always make sure to put parentheses because you're going to do mistakes here. When you're using calculator, plug in with the parentheses. Because is that the same? Squared only for the 3. 3 squared is 9. And there is negative sign, so the result from here is what? Negative 9. Here, it's squared for both, negative sign and 3. Negative 3 times negative 3 is going to be positive 9. You see the difference? So always put parentheses. If you want to use the calculator. Now, 2 negative 3 squared is 9. Negative 3 times negative 3, positive 9 plus 1. 2 times 9, 18. Plus 1 plus 9 plus 1. So it's going to be what? I don't know. Is that hard? Maybe the same thing with number A and this one. It's an A. I didn't know that. I just saw it. It's an A. The same thing. Don't confuse yourself.
So the 28 equals a y, right?
Perfect. 28 is the y value, is the output, the y. So if you want to write down as a point, the x is negative 3 and the y is 28. Okay? Is that fine? Is it okay? Can we do the same thing when we have an A? F to the A. Now the input is F to the A is going to be what? What do you think? Here's the function. You're going to plug in A where? That's it. 2 A squared minus 3 times A plus 1. It's going to be 2 A squared minus 3A. That's it. That's the y value because you don't know how much is going to be the A. Okay, so this is the y value. Okay, and the last one, can we do the same thing? Let's start with here. So f to the 3 plus z, which is equal. I'm going to plug in instead of each x, but this one you have to simplify. Let's do it on that side. Which these? We have our function is 2x squared minus 3x plus 1. Now I need to find f to the 3 plus z. Plug in 3 plus z instead of each x. So maybe 2, 3 b plus z squared minus 3 times b plus z plus 1. Is that okay? Now what's the next step? Yes, this is right, but you have to simplify it.
We gotta multiply, we gotta distribute.
Yeah, here you're gonna FOIL, here you're gonna distribute. It's fine, I know what you meant. So it's going to be 2. You can write down like this times what? Minus 3 plus z plus 1. Which one are you gonna choose? You're gonna FOIL this one first? Therefore, there's a 2 here. 3 times 3, 9. 3 times z, 3z, that's 3z again, plus z squared. Is that okay? Okay. I'm just spoiling these two. I'll distribute this number. Negative 3 times 3 is negative 9. Negative 3 times z, negative 3z. Now, do I have to combine the like terms now? Do I have to combine the like terms? I'm going to combine the like terms only here. After that, I have to distribute 2. So it's going to be 2, 9 plus 3z plus 3z, 6z. It's going to be fine if you distribute the number and then combine the like terms. It's going to be the same thing. Plus z squared minus 9 minus 3z plus 1. 2 times 9, 18. 2 times 6, 12z. 2 times z squared, 2z squared. Minus 9 minus 3z plus 1. Is that okay? And what's the last step?
Combine like terms.
Combine like terms. I'm going to write down 2z squared first. 12z minus 3. 12z minus 3. That's 9z. What else we have? We have 18 minus 9. It'll be 9 plus 1. Is that okay? Let's see, number 13. Our function is g of x equal g of x equal square root of 6 minus 2x. Now we need to find g of 3. What does that mean? I'm gonna plug in 3 here. The square root of 6 minus 2 times 3 equals square root of 6 minus 6, which is equal square root of 0, which is equal 0. Is that hard? Well, then next one. Plug in 4. G of 4. Square root of 6 minus 2 times 4, which is equal square root of 6 minus 8, which is equal square root of negative 2, which is equal 2. All right? How much going to get the result?
Plus or minus
Again?
plus or minus I2.
No, because we're not taking the square. Okay, taking the square root of negative 2. There's the plus or minus. What else? Negative sign is going to be what?
Right.
And keep the square root of 2. Okay? Next one. Of course, they'll be undefined with this one. So if you, I don't know, if you plug it like this one, it should be right as a result.
Like
Yes.
that.
Yes. Because why? Because they ask you to evaluate and simplify. I don't think so on Alex, they're gonna ask you to go further than this one. Let's go to the C, which is G of -4. G of -4 is equal what? Square root of 6 minus 2 times -4. The square root of what? 2 times -4 is going to be 8, -8 plus 6, -14. That's it. I don't think so they can accept decimal numbers.
I have a question. I don't know if you already said it, but what's the G stand for, or it's just
Just a function.
function?
Yeah, like, don't confuse yourself. That's a good question. Sometimes you can all the examples with alpha fill x. All the examples with alpha. So you're gonna think, oh, that's the only. No. G of x. T of x. It depends about what's the variable you're using. So all these functions with respect to the x, okay?
Okay.
But they keep using f of x. All functions with, because now we're gonna take application with the time. So we use the variable t as a time when we take application, okay? Let's see. Find the x-intercept and the y-intercept. Find x and y-intercept. And they're telling you here on the top. What are they telling you? X. See the function y equal up fill x? X-intercept are the real solution to the equations of. Use this one. So put circle on this node. Put important. It says the x-intercept are the real solution of the equations. When alpha of the x equal, what does that mean? How to find the x-intercept? Remember that? To find the x-intercept, they're telling you set the function equal 0, which is mean the y. So we already know to find the x-intercept, you're gonna let y equals 0, which is alpha of x equals 0, the same thing. Alpha of x is mean the same thing, the y. And to find the y-intercept, you're gonna let x equals 0. That's it. That's the two golden rule. Find that intercept. But we're gonna, in some point when we study how to solve polynomials or graph it, x-intercept is the solutions when x equals 0. We need to find the x-intercept. That's why we're gonna keep doing the same thing. I want to find the x-intercept for this equation, number 14. We're gonna let y equal x squared minus 4. Is that the same thing? Is that the same thing? Alpha of x equal x squared minus 4. So if I say y equal x squared minus 4, is that the same thing? Yes. Same thing. So to find the x-intercept, we're gonna let y equals 0. I'm gonna put 0 here. 0 equals x squared minus 4. Now how I'm gonna solve this one?
0 equals negative.
So add 4. Yes or no?
Yeah.
Okay, so let's add 4. Before equal x squared. Take the square root. That means x is going to be equal plus or minus 2. How many x-intercepts do we have?
What?
How many x-intercepts? 2. Which is 2, 0, and -2 with the 0. Okay. Now on the other side, we're gonna find y-intercept. It's not a minus. This is how they type it. So we're gonna let x equals 0. I'm gonna plug in 0 where the x. So that means y equal 0 squared minus 4. Y equal what? So how many y-intercept? One y-intercept, which is 0 and negative. Good. All question. Now the same thing with example 15. To 15 here. G of x equal 3 minus absolute value of x. Let's find the x-intercept. X-intercept, and let y equals 0. Where is y here? G of x, it's mean the y. So G of x is the same thing as the y. Is the image of x. It's the output of x, okay? We're gonna put 0 here equal what? Minus absolute value of x. Now how am I gonna solve this one? Tell me.
Absolute value of x equals 0.
So what I'm gonna do?
Subtract 3.
3. Okay, can I move? Okay, let's move the 3. How? Say minus 3. Okay. So minus 3 from both sides. Cancel here. So negative 3 equal negative absolute value of x. Right? The next step, I have to keep the x by itself, but there's negative sign outside the absolute value. So I have to divide both sides by negative 1. So maybe the absolute value of x equal what? 3. How are we gonna solve this one? If we're gonna go back to the,
It's not a minus.
it's a plus or minus. You remember when I told you the absolute value of x equal k? If k is positive, how many solutions we're gonna get? No, 2. We're gonna get 2 solutions. If k is positive, we're gonna get 2 solutions. If k is negative, no solution. 4 cases on section 1.6. Took 4 cases about the absolute value. So now x is going to be, k is what? Positive. It's a positive. So that means x is going to be plus or minus 3. So we have 2 x-intercepts. And negative 3 would. Okay. What else we need to find? The y-intercept. How are we gonna find the y-intercept? Let x equal 0. Yes. So y-intercept let x equal 0. Put 0 here. That means g of x equal 3 minus absolute value of 0. That means y is going to be equal about 3. So it's going to be 0 and 3. Gone. Put there 0, 3. Next one, number 16. Let me ask you. X equal what? 2 minus square root of x. Need to find the x-intercept and y-intercept. So x-intercept, and then where's y? H of x is the same thing to y. So 0 is going to be equal to 2 minus square root of x. How are we going to solve this one? Here, how are we going to solve this one? Come on, how are we going to solve this one?
Subtract 2, put it on the other side.
Okay, minus 2. Oh, wait, perfect. So the negative 2 equal what? negative square root of x, then divide by
-1.
-1. The square root of x is going to be equal to. Now I need to find the value of x. What I'm going to do?
Square.
Square, not square root, square both sides. So x is going to be equal. So how many x-intercept? Now to find the y-intercept, let x equals 0. X equals 0, that means h of x equal 2 minus square root of 0. So y is going to be equal. It's going to be 0 and 2. Okay. Okay.
Is 0.3.
No, 0.3. What's the domain? Check the graph. Both going up, right? So going to where? First of all, let's check here. From here goes where? Negative infinity as an x. And from here going to where? As an infinity. And we need to focus on the x value. So just visualize a little bit. If you took, because each point here has x and y, right? Each point on the graph from this side, x and y. So if I took the graph here and I put it on the x value, on the x coordinate, so the graph from this side goes where? Negative infinity. Is that okay? Because I'm telling you again, each point on the graph, it's x, y. So I need just to focus on the x. I'm gonna ignore the y. So if I took the graph and put it down on the x coordinate,
In the very bottom.
yeah, on the x, which is the x coordinate, the graph is gonna go where? To infinity, because you have the arrow. That's mean they're telling you the graph going to infinity from both sides. The x value, I'm just focusing on the x value. Always you're gonna write down the domain from the left to the right. So to write down the domain is going to be from the left to the right. Is that okay? Fine. And always parentheses with the infinity. There's no bracket with the infinity. Always parentheses. When you see the infinity, you have to put parentheses, not a bracket, okay? The range, you said, how much the range? Right. Check here, which is the y value, right? The range is mean the y value. Now check the range. We're gonna look to the y coordinate. The y coordinate, the graph starts from where? See, from 2, starting from this point, and goes where? To infinity. So the range, you're gonna write down the range from the bottom to the top. You write down the domain from the left to the right, because if you flip it, it's going to be wrong.
So the range is from the bottom.
To the top. Now the bottom of the graph, from where? From this point, right? From 2 and goes where? To infinity. Always parentheses with the infinity. Now check the point here. Is the point include the graph? Yes or no? The point here, the y is included in the graph. So we have to put a bracket here. Is that okay? Fine with this? What we have here? Domain from the left to the right. The range from the bottom to the top. Okay? Let's do the same thing here. Let's tell me the domain and the range for number 18. The domain. Start with the domain. Look to the x value. Yes, the graph, there's a gap here. Remember what I told you? One close, one open, always. You can't be close on a close. That's wrong. I told you with the graph, there is something wrong. So always one open, one close. Oh, this closed, this one could be open. Now, in general, the domain, if you took this side, this is the x. If If you took this side and put it down, goes where? If you took this side, I'm focusing on the x value, and just put it on the x, goes where? Infinity. So the domain is going to be from where? Negative infinity to positive infinity. Is that okay? What about the range? Where is the lowest point on the graph? The lowest point here, right? So this is negative 12, negative 11, negative 10. That's mean from negative 10 and goes where? To infinity.
Just ignore the points on the graph,
Oh, which point?
the opening close.
Because with the opening clause, we're gonna ignore it. Why? Because the y is defined here on this part. This is undefined here, defined on this part here. So it's still including the range. That's a good point. Yeah, the range is not defined here, but the range in general from this one and goes to the infinity. You don't have to put two parts.
So, like, let's say it moves to the left and one moves to the right. Would it be different? Like,
Oh, wait, which one? You're talking about this one?
yeah.
Yes, it's gonna be different with the domain.
Okay.
If there is a gap like this, I think there's an example. If there's a gap like this, it's gonna be different. I think there's an example one of there. So the range is going to be from where? Negative 10, don't forget the bracket, to infinity parentheses. Is that okay so far? Number
Do we,
19.
do we just look at the solid dot one or the other one?
We're talking about this one? 19? First of all, tell me the domain.
What I put is 2 and 4
You put
for the solid dots.
so first of all, the domain. The domain. Every time when you see the arrow here, it's mean they're telling you the graph keep going. So from this side, the graph going where?
All the way.
Oh, yeah, so negative infinities. Comma. Let's see. X value, oh, if I took this one, the X value end where?
4.
Because there's no error, that's mean the graph is stopped here. But yes, at this X value, when X value is 1, how much the Y? How much the Y at X equal value? This one or this one?
1.
No, not 1, because this is open circle. So the Y when X equal 1 is what? 2. I'm talking about at this point. When
Okay.
X equal 1, how much the Y? 1 or 2? When X equal 1, how much the Y?
Both of them?
You can't say both of them. That's a good point. I wanted you to say both of them. The closed circle, the open circle is not defined.
And around it.
It's going really close to the open circle. But then when it's reach 1, it's gonna go where? 2. You got it? So when X equal 1, the Y equal 2. Is that okay? But as a domain goes where? To the, no, not 8. To the X, which is 4. I have to put what? Bracket from this side because it's a closed circle. Every time, yes, every time when it's a closed circle, you're gonna put a bracket.
Yeah.
When it's an open circle here, you're gonna put what? No, parentheses. Write down these notes. When it's a close, you're gonna put a bracket. If this one is open, you're gonna put what? Parentheses. Is that okay? What about the range? What extra points? Okay.
Bracket 0 to
So tell me how we're gonna add down.
row parentheses.
Parentheses like this. 1,
Parentheses.
close it. Okay.
Or a U for connection.
Okay.
Bracket
Bracket.
2.
Okay. get extra points. Because here's the thing. But we have to fix it. The bracket and parentheses it represent a set. So when you put a bracket and parentheses like 2 and 5, which is mean everything between these two numbers. When it's not a point, we not write down the point. Wait, don't confuse yourself. Now we're working with domain and range. It's a set. A set all the numbers, okay? So when I'm typing 2 like here, negative infinity and 4. This is not a point. This is all the numbers from negative infinity to 4, including the 4. Is that okay? Number 1. Why he said 1? Because check here on this constant part. How much the y value? It's fixed. 1, 1, 1, 1, 1, 1, 1 here until this point. It's all 1. So we can't write it down with parentheses. We have to set is the set of all number 1. Okay? But I'm telling you, on the test, if you put parentheses, I'm going to consider it right. Union, because we have a range here, and there's a gap, and we have another range. So we have to include all the range. So we have to put union sign. Okay? That's mean I have this part plus this part. Our range, right? Which is started from where? From 2, I have to put a bracket because it's a closed circle. Until where? Until 8, I'm going to put a bracket because it's a closed circle. Is that okay? Any question? Any question so far?
So when it's written down, that would go when you see the word and, right?
Say it again.
See or, then you wouldn't do it like that.
You see what?
Oh no, it's just on I think I was doing it on Alex.
You have to put the sign, this one. Like from this one, they're going to give you an option on the side to use the union. Okay? Same thing here. Exactly the same thing, but now with what? The die. What's the domain? What's the domain?
Infinity negative.
Check arrow from here and arrow from here. So it's going to be what? That's it. Gone. What about the range? What about the range? Just they're confusing you about this point. They need you to figure out if it's right or wrong, but as a graph, this is wrong. It should be open circle. You can't do that because this point, the x is already, the y is here, right? So just like to confuse you. Because it's already when x equals 1, this is -3, -2. When x is -2, the y is here. You got it? Because this one goes to infinity. So the range from where?
-3.
Okay, parentheses negative infinity to where? To the 4. I have to put a bracket here. It's bracket because the end of the range is at this point. It's not the graph. Okay. With x-intercept, y-intercept is not maybe that much hard. You can do it. Tell me the domain and the range. What's the domain? Okay.
Negative infinity, positive infinity.
That's it. So the domain going to be negative infinity, positive infinity. What about the range? No. Because check here,
Oh,
there is a gap.
Two.
There is a gap. The function is undefined here. So now, write down the range for this piece. Write down the range for this piece. This one goes where?
Negative infinity,
Okay, so negative infinity to where?
it's one. bracket,
Negative one. Bracket. Write down the second piece.
Parentheses, one.
One, which is this one, because here's the undefined. One to where?
Infinity,
Bracket, one to infinity. Put union between them. That's it. Is that okay?
you said the one takes a bracket too, even though
Why?
it's a circle?
What? Because not this one. This is undefined. This one. The y here. Okay.
So
It's
we're
on the same line.
gonna use that one then.
Yes. Because at this point the y is undefined. The y at when x equal -1, the y value here, not here. But at this point, the y value yes defined. When x equal 2, the y equal 1. Okay, so this one's going to be the minimum point of the range. Is that okay?